Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. Now, if you have any questions throughout the session, if you're watching on Zoom, just look at the top of the bottom of your screen. Wherever your Zoom controls are, you should see a little button that says Q&A. Click on that, type in your question, and I'll get to those at the end of the session. If you're watching along on YouTube, just feel free to use the live chat function if you're watching live. Otherwise, just feel free to leave a comment, and I'll get to those when I can. So my name is Jason Gabrinas. I'm one of Snap-on's national diagnostic technical trainers. Been in the training department the last 11 years or so, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, I was a couple years as a diagnostic sales rep with Snap-on. So I had about 30 different franchisees I worked with, as well as the shops that they service in order to help everyone get the most out of their diagnostic needs. And before I did that, it was 8 years at Subaru. So worked in a dealership, and I guess over time became that default diag guy in the shop. So I always ended up with the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. And before that, bunch of other miscellaneous wrenching jobs, been a little over 25 years under hood experience for me. So our topic today is modern ABS systems diagnosis and repair. So we've spoken about ABS before to a point, but if we think about what is ABS used for, or at least the system of ABS, what do we use that for nowadays? We use it for more than just stopping the car without skidding. So that'd be your ABS, of course. But then we have traction control, stability control, hill descent control, hill hold start assist, cornering brake control, trailer sway control, automatic emergency braking, and intelligent cruise control, just to name a few, because I'm sure there's other systems. This is just what I kind of caught off. This real F1 vehicle is what they use the ABS components for. So if we think about um, just our general first ones that we had. So ABS was of course, the brake force control. It's going to slow down the vehicle. Uh, Traction controls when I'm in the sand or something like that. So I can go forward. And then stability control is just to keep it from rolling or pitching or what have you. So it keeps the car going straight down the road. Now, with the new systems, you're not necessarily even connected from the brake pedal to the master cylinder. It's all electronic at that point. So it's like brake by wire. We had drive by wire. Now we have brake by wire. And that way, the ABS module, the hydraulic unit, and so on, can pump the brakes independently. If it needs to just tap the right rear a little bit to bring it back in line, it can do that now. So they're a lot more complex. There's a lot more things driving the brakes, and a lot more things that the brakes are used for on the vehicle. So with that, the different system components that you might find that all can affect the way these systems work, not just ABS, but the other systems that we have. Wheel speed sensors, that's pretty standard across the board on all those. Just so the vehicle knows what speed each wheel is doing, and that's how it can also help with traction control and stability control and things like that. Steering angle sensor, because I need to know what the steering input is. Steering effort sensors. There's torque sensors on a lot of cars nowadays that show how much effort the driver's putting in. Brake pedal position sensor, not just a stoplight switch anymore. It's a brake pedal position sensor. Brake pressure sensor to tell what the pressure of the fluid is. Yaw rate sensor, hydraulic unit, pump, control module, and other ADAS components, right? Like we said, can feed that as well. Automatic emergency braking is another one that comes to mind, right? Not just intelligent cruise control, but they have the automatically can stop your car if a vehicle 3 cars ahead of you slams on their brakes and you can't see it. It'll know that traffic is stopped, and it'll slam on the brakes for you. So it's all this stuff is interrelated now. It's way more complex than it ever used to be. And if we just see, this is a simple one off a like a Ford Explorer, if I recall. And things like the different switches go in, instrument cluster, HVAC is part of this. Gateway module, ABS module itself. We have the hydraulic pump motor, hydraulic valve solenoids, hydraulic pressure sensors, actuator position sensors, brake fluid level switch, wheel speed sensors, and all these other systems can depend on each other in order for in order for it to all work. So let's start with the wheel speed sensors. So three different types of sensors that we would have would be, well, it would be either analog or digital, really, is what it boils down to. And they can be either inductive or they can be magnetoresistive type sensors. So on an inductive sensor, it uses a magnet, and we have a ferrous rotor. So that's going to be steel, cast iron, probably not, but more than likely stainless steel. You're gonna have an air gap in there, and as the spikes here, or the teeth on the rotor spin by, it has a magnet, and it has a coil in there, and it's going to generate a voltage, and it's going to kind of look like a sine wave if you were to look at it on a scope. You can see that. So as it goes, like I said, it's going to induce a current through that coil, and it is going to generate a sine wave. Now, one common failure point here is if we have an issue with the rotor, either damaged or rusted or what have you, it's not going to make the magnetic field work the same way. So if I were to have this, right, and then all of a sudden we got a flat spot. All of a sudden we got a flat spot as it's spinning around. So what is the vehicle to think? If it sees a flat spot on the signal, what's the computer going to think? Well, it's not moving. That means it's locked up. So that means I need to pump the brakes. So I know my mother's vehicle many years ago, she had an '01 Ford Explorer. And when it would come down to a stop, could be dry, perfectly sunny, 80-degree dry day, and the ABS would fire no matter what. So long as you get below a few miles an hour, it would just act like the ABS was going off, and it took them a while to figure it out. But when they did finally figure it out, they checked the rotor. It was rusty. It had some rust on it. Actually, dealt with that a few times at Subaru as well. So it's a fairly common failure for that. And as we'll see, anything that kind of gets in the way, no matter what it is, it's going to do that. So in this case, as wheel speed changes, frequency and min-max voltages change, and that's that '01 Explorer I talked about. Kind of as it would go up and down, it's going to get closer together the faster the wheel goes, and it'll get further apart, and the amplitude goes down. So as it spins faster, the waves will get closer together and bigger, and as it slows down, they'll get smaller and they'll get further apart. That's how the computer can tell how fast the wheel is spinning. Then we have magnetoresistive sensors. So there's both passive and active types, and the passive works very much like we were seeing before. But an active magnetoresistive sensor here, it actually, instead of the magnet being in the sensor, it's actually in the ring, the magnetic rotor. Usually it's going to be the inner bearing race on the hub there. So you usually see that. And it has two sensors there, magnetoresistive A and magnetoresistive B. And you see we have south and north poles on. So it's got an internal chip in there, and it figures out and it generates a square wave based on what it sees. So the other thing that we can do with a magnetoresistive sensor is it can also tell what direction the wheels are going. Are they going forward or are they going backward? Because the north and south poles will hit A and B differently. So the north pole hits A first, and then north pole hits B. Then it's going to send out a square wave and a square wave, and it'll generate just a basic square wave. If it goes backwards the other way, south is going to hit it first, and then north. So it sees that, and then it knows, well, it's going the other way. So then my signal goes up, and then it puts out a modified square wave so that the vehicle's computer would know it's going backwards. So it knows whether you're going forwards or backwards, which helps us with braking, yaw control, stability control, traction control, all of those things. It's going to help out with that. So the more advanced, they get a little bit more advanced as we go. So this is an example of one of those on a GMC Acadia. Wheel speed sensor is a 12-volt digital sensor. The electronic brake control module sends a 12-volt reference voltage signal to each wheel speed sensor. As the wheel spins, the wheel speed sensor produces a square wave DC signal voltage. The wheel speed sensor increases the signal frequency as the wheel speed increases, but does not increase the amplitude. So the frequency will get closer together, but the amplitude will stay the same. It'll be like a couple, it's only a couple volts. And then we have our pin assignments here. And then if we go on to the lower part of this, it's going to show us the what the square wave would look like. It's going to look very much like that, just a general square wave. Now, here's an interesting tech note, and they actually have a TSB on this from GM. And it's on some vehicles, the following DTCs or symptom codes may be set. In addition, the following lights may be illuminated: ABS, service, traction control, etc. May be caused by bits of ferrous magnetic debris stuck to the wheel speed sensor magnetic encoder ring. Remember how we talked about the inner bearing race is a magnet now. It's got south and north poles. So as the knuckle, which that hub and bearing assembly is going to be in, it's going to rust over time. Unless they're aluminum, which is more than likely isn't, it's going to rust, right? So the vehicles use a speed sensor encoder ring with north-south magnetic pole pieces encased in a nitrile rubber ring, typically brown in color. This ring is part of the wheel bearing. If you experience any of these symptoms, the ring may be cleaned using a soft nylon bristle toothbrush or equivalent. If any debris still remains, a mild soap detergent may be used. Wipe dry after the procedure. Use care to prevent damage to the wheel bearings. Don't use a magnetic tool to remove the debris. It's like, oh, it's just a bunch of rust or metal flakes. I'll just take a magnet and go around there, and you're going to screw up the magnet that's on the encoder. So we don't want to do that either. And then from the bulletin, here's their artist's rendering of what that might look like. I guess they couldn't find a picture of a real one. But yeah, just a bunch of stuff on the inner bearing race, right? Bunch of metal flake basically is what it is, because like I said, that it's gonna rust, it's gonna flake off, things move, it's gonna stick to the first magnet it's got. So there you go. Another one that's a bulletin. This is from Volkswagen Passat. And apparently those have a left and right on some of the speed sensors. So if I put the left one in the right side and the right side in the left one, then we can have a problem there. So you can see where it's kind of worn off there, and how it's destroyed the encoder ring on the inside there. You can see how it's just kind of wore off. Whatever was protecting it's all worn. So be aware of where things need to go. Here's just another example off a Dodge Charger. So that actually does a little bit of math. So raise the wheel in the air. As the wheel spins, sensor will produce a square wave that varies by about 400 millivolts, cycling between 10.4 and 10.8 volts. And then the meter is set up to focus on that difference. So you see it's not much. It's 4/10 down the bottom, and then a negative 4/10, and then like a positive 4/10 on the other side. And this is just kind of pushing it by hand. Now remember also, to all these interconnected systems, if I'm going to try and check the wheel speed sensor or check a wheel bearing or anything where I need to have the vehicle's wheels moving in the air, if they're the drive wheels, I'm going to have to turn traction control off in order for that to work as well. Because all it's going to see is just the wheel slip, and it's just going to pump the brakes. So usually there's going to be a traction control off switch in the cabin. Just make sure you press that before you spin the wheel. It's a simple thing, but don't always think of the simple thing right off the bat. And here's another note on a modern speed sensor as well. Do not unplug the connector while the key is on. The ABS control unit shuts off voltage if a sensor is unplugged. So I have to leave everything connected and plugged in order for it to, or even be able to test it. It's recommended to use a scanner to check the wheel speed sensor PID data streams. Inspect the electrical connectors for looseness and poor male to female terminal pin fit. Make sure the air gap is correct. Check the speed sensor and tone wheel for debris or damage. So this is kind of rolling everything all up into one. Carefully inspect speed sensor harness for chafing against suspension components or other damage. Voltage at the power terminal of active Hall effect sensor will approximately 0 if a DTC is set for the wheel speed sensor being tested, or if a sensor is disconnected. Resistance testing with active Hall effect sensor is not a suitable test. So you can't test them like you used to test the old ones and test for continuity or any of that. You can't disconnect it and expect to get a signal. Basically, as soon as it disconnects or it notices any issues with it, it will turn off the power to it. So that makes it just one other wrench in trying to, or one other wrinkle into trying to diagnose these. So next sensor, yaw and steering sensor. So a yaw rate sensor, what that's going to do is it's usually centered in the car, and it's going to detect the vehicle yawing back and forth. Right? They call that that angle yaw, going back and forth like that. So in this case, yaw rate sensor, G rates, G sensor detects changes in vehicle direction, detects motion by moving electrodes built into the sensor. Sensor will send ABS control unit a signal by changing voltage. And you'll notice this one says it's located in the center console next to the parking brake assembly, so right in the middle. And then this one, some vehicles that have a multi-axis acceleration sensor. So yaw rate and lateral acceleration sensors are combined into one multi-axis acceleration sensor module, external to the electronic brake control module. The electronic brake control module receives serial data inputs from the yaw rate, longitudinal, and lateral acceleration sensors. So it knows if it's going up or down hills, left or right, side to side, and front to back. Then we have steering angle sensors, so the vehicle understands, I'm steering one way, I'm steering the other way in degrees. Usually, it's in positive and negative degrees, and that has to be reset after an alignment, right? And then on the other end of the shaft on some vehicles, it's going to be a torque effort sensor, so it understands how much torque is being applied to the steering wheel as I'm steering. Am I doing it just a little bit, or am I really, really heaving on that so that if I know I'm making an emergency maneuver, the vehicle is going to act accordingly. And then we have our brake pedal position sensor. So you'll see this does not look like a regular brake light switch because we don't use a brake light switch anymore. We use a brake pedal position sensor. Now, it's not on every vehicle, of course, but on the vehicles that do use them, it basically just runs that looks like a really old school throttle position sensor that you might find that had the little it's got a little nub that rides inside those fingers there, and it just kind of sweeps it back and forth. So it's kind of very similar to that. So body control module monitors the brake pedal position sensor and sends a serial data message to the electronic brake control module. When the brake pedal is applied, the electric brake control module compares the correlation between the brake pedal positions and the brake pedal position sensor, sense the driver's application of the brake pedal. Body control module turns the brake lights on when the brake pedal position sensor changes state. It's also used for the hill start assist feature. The other section of the switch controls the rear brake lights. So some of the switch uses the brake lights, sends a signal. The other one sends a signal to the actual module itself. And then we have our pumps and hydraulic units. They all work fairly similar. There's solenoids that open and close. So in this case, we have our pack here, and then we have our hydraulic unit there. And we have solenoids. And so the hydraulic unit itself is going to be the pump, and then it's going to have the open and shut valve. It's going to have an open valve and a closed valve, and it can open them tens of times a second, hundreds of times a second, I think, on the newer models. But it works kind of like this. So let's start the video. There we go. It's going to detect the brake slip. It's going to send a signal. It's going to charge up the solenoid. It's going to open up one of the valves to maintain the pressure. And then it will then pump back and forth to open and close the calipers. Right, so that's open. And then it opens and closes as you see right here. So that's the sound you would hear, and that's the what you feel in the brake pedal as well is the pump opening and closing. You got open and close valves there. So it's got like burr, like a burr noise, right? You would hear that, and you would feel that in the pedal as well. So when you need to internally bleed it, you would have to do that. Right. So that's just kind of how it works inside the solenoids, open and close. You got a little accumulator right there, and then this is the main valve opening to allow pressure through into the brakes. All right, and then as far as ADAS components are concerned, like I said, these can also affect it, or ABS failure can affect your ADAS. Kind of works both ways. So we got cameras, we got radars, we got different control modules all together. There's a radar there behind the hood for the automatic cruise control. Here's the brake pedal position sensor, right? So it's all around the vehicle now. We have to be concerned about all these different components that feed into both they use the brake system and they also feed into each other. If the brake system failure can cause a failure in ADAS, ADAS can cause a failure of the brakes. And all these systems, like I said, the components are interrelated now. It's not as simple as it used to be. It wasn't the simplest thing in the world either when it first came out, ABS and all that, but now it's definitely not Simple. And then I also have to worry about like changing brake pads. I have to put the vehicle in maintenance mode and things like that. Um, so there's a lot of things that you definitely need to be aware of and think about when it comes to working on these systems. So let's go look at a couple of vehicles in here and we'll see. So let's start with the old Explorer, right? That 2001 Ford Explorer. That's, like I said, that was my mother's old vehicle. And we had four-wheel anti-lock brakes in here. And you see codes data functional tests. Under functional tests, we're going to have an automatic brake bleed procedure for that, which is good to have because you not only to bleed the brakes themselves, but also there are some vehicles where you need it in order to bleed internally in the pump to do any pump work. Pump motor tests and output state tests, which will change the inlet and the outlet valves on and off that we saw earlier. I can turn them on and off to test them and see if there's any issues internally. You're probably just going to get a pump anyways if it's an issue, or a hydraulic unit anyways. But, and then we see, in this case, it's a four-wheel ABS system, but it only has 5 PIDs. I got left front, I got right front, left front, right front, and rear. Because it's got 1 wheel speed sensor on the back and 2 in the front. Whether there's a DTC and whether the brake on/off switch is on or off, the boot. So back in 2001, man, you miss you miss those vehicles, right? Where they're super simple back. And if we go into guided component testing as well, we have, like I said, 4-wheel 3-channel ABS. We can information on the module itself. We got a connector pinout in there. Shows us what everything does. Once again, not all that complex back then. Module location, left rear of the engine compartment, and then component information, how it works, what it's going to do. And that one just has a G switch, ABS warning indicator, hydraulic control unit, sensors, and indicator. And then we brake fluid level switch, brake pedal position switch. So even back then, brake pedal position switch is a normally open 3-pin connector that's located in the brake pedal support underneath the instrument panel. It's fed by a 15-amp fuse through pin 3. It's hot at all times. Brake pedal is depressed. The brake pedal position switch is closed, completing the circuit. Switch is grounded through pin 1. Once the circuit is closed, the signal is sent through pin 2 to the ABS control module. So it does send a signal to the ABS control module, and it turns on the stop lights. All right, and then things like parking brake, wheel speed sensors. We could go in here and we can take a look at that. So it's 3-channel brake system, 3 variable reluctance sensors to determine vehicle speed. Sensors are located on the right and left front wheels. As 1 sensor mounted on top of the rear axle. It tells us how it works. Some sensors fail intermittently, may need vehicle at normal operating temperature to isolate the failure because temperature can affect that as well. Road testing vehicles on rough, uneven roads may help with diagnosing intermittent problems. Road test a vehicle using a scan tool. Look at the wheel speed sensor PID data if available. Look for any erratic reading. Also compare sensor readings that should be close within plus or minus 2 to 3 miles per hour. Good to know. So that's the old one. Actually, before I go further, I also want to remind you, if you have a Snap-on scan tool with the guided component test feature that I'm showing here, you also have built-in classes. And 2 of the classes under how to are going to be for ABS. So if I come down, here's a 20-minute anti-lock braking class. Operation of the system, basics and fundamentals, testing active wheel speed sensors and testing inductive wheel speed sensors. So it goes in a little more depth. And then also in there is a, where'd it go? 20-minute brake electronics class because it has changed a bit. So a number of extra components have been fitted to vehicles with anti-lock brakes or ABS over the last number of years. This allows extra safety features such as brake assist, electronic stability program to become available. The following section is an add-on to the anti-lock braking class and is designed to explain further the function of these components. So we talk about yaw rate sensor, lateral acceleration sensor, steering angle sensor, sensortronic brake control, etc. So it just kind of shows you a rough overview of what that would look like. So that's inside the tool as well. A little bit of training on that. Let's go to my next vehicle, which is going to be my 2011 Forester. So we go in here and we would go to anti-lock brakes and automatic and functional tests, right? So we can go in there. It's ABS sequence control. What that does is that it'll process through the ABS system. It'll fire the solenoids. You have to push down on the brake pedal, and then it goes, it goes through each 4 channels on there to pump it. That's also a good way to bleed it. It's not an automated brake bleed, but it's a good way to bleed it. And as far as guided component tests, go into ABS again, ABS module. In this case, we have module location again near the brake fluid reservoir on the passenger side near the front of the engine bay. Hydraulic control unit. It's going to tell us how it works, gives us the pinouts. Wheel speed sensor on this one. The tone wheel for the ABS and VDC has been removed, so that's vehicle dynamics control, which is like stability control. They removed from the axles and replaced with an encoder ring that's fixed to the wheel bearing. So these are the magnetoresistive. Speed sensor has been redesigned to work with the encoder rings and mounts through the wheel bearing housing. It's a Hall switch type. It's actually just part of the wheel bearing. The encoder ring is adhered to the wheel bearing outer shell. It's not serviceable. Small magnetic strips are incorporated in the encoder ring to provide the pulses to the speed sensor as the wheel rotates. And then if we wanted to do, say, a signature test, it's going to show you that. You're just going to hook up to it and you're going to check the signature. Let's go to 2020 Acadia. Actually, let me, scanner 2. Scanner, check that. So ABS, functional tests. So we have an automated brake bleed here. This actually bleeds the whole system. So connect the required brake bleed equipment. So there's a pressure cylinder that you need and a couple other things. Connect battery charger. Ignition must remain on or run. Connect the bleeder ball to the vehicle and set the 300 kilopascals. Do not open bleeder screws. It'll initialize communication. Basically puts it into a learn mode where it will allow it to flow. Attach the bleeder ball to the right front bleeder screw. Open the right front bleeder screw. Brake fluid will be under pressure. Secure the bleed hose and open bleeder screws slowly. And then you would just continue, and it's going to have you go through each of the 4 corners of the vehicle and bleed it. As far as output controls, we have the pump motors, the solenoid valves, also caliper pistons, extend and retract on those. Parking brakes as well. So left parking brake actuator, right parking brake actuator. You may need to do those in order to service the brakes. Yaw rate sensor learn as well. Vehicle needs to be on a flat surface, and it's basically going to learn a 0 point. So you don't want to be in the car. It needs to be on a flat surface. Flat, level surface. Get out of the car. Make sure nothing's in the car when you're doing it. As far as guided component tests, vacuum sensor for the brake booster. Some vehicles have that as well. Sometimes you need supplemental vacuum for that. Electronic brake control module, parking brake actuator, parking brake switch. Let's see, electronic power steering, which is considered part of the ABS. Right, so a lot of serial data in there. Power steering control module has the ability to detect malfunctions within the electronic power steering system. Any malfunction detected at disable steering assist will cause the service power steering message to be displayed on the driver information center. Additionally, power steering control module calculates an internal system temperature, which is used to protect the power steering system from damage caused by high temperatures. So a lot of good knowledge there. Wheel speed sensors again. Let's see. These are the ones that can get the iron on them. So 12-volt digital sensor sends 12-volt reference voltage signal each wheel speed sensor. And if we come down all the way down here, it's located at each wheel hub and the steering knuckle assembly. And it's just part of the bearing. And then lastly, we have a Hyundai Palisade, pretty popular newer vehicle. Call it an all-wheel drive. Okay, anti-lock brakes. System tests. We're going to have brake pad change mode. Right. So remember how I said you may need to do that to change the pads. Now, I will say, as kind of an aside, because I get questions about this probably at least once every other week on different braking systems. It depends on the manufacturer how they do it. Some manufacturers, it will actually retract the caliper. Other manufacturers, it basically just releases. There's an electric motor. it releases that, and you have to manually push them in, or you have to manually screw them in still. There's some that do that as well. So you need to understand what vehicle you're working on. Even across the same manufacturer, they could have different ways of doing it. Before changing brake pads, this function should be performed. So allow you to push the piston into the caliper by retracting the spindle nut with the actuator. So it'll retract the spindle nut, but you still have to push it in. So you need to understand that. And then you continue. It's going to do the thing. This may give me an error because it's in simulator mode. Guess we'll find out here in a second. Give it a second. You would normally hear stuff retracting, I would guess, in the back too. And it's going to hang up. Nope, test complete. All right, so that means it's retracted. And then you could go in and push in the caliper. Now, after change, it's going to do the opposite, right? So it's going to be after changing brake pad, apply and release. The function should be executed 3 times. You now use this function while the brake pads are being replaced. Please make sure to take general safety precautions before acting. It's going to close. So that's important to know. This one also has automated air bleeding as well. Steering angle sensor calibrations inside the brakes. Longitudinal G sensor calibration as well. And then any other functional tests. Let's see if it's going to load a list or not. Once again, in a simulator, doesn't always show everything. All right, but you'd have your various output controls in there. All right, and then if we check under guided component tests here, ABS, say the ABS module, there's even a location image on this vehicle. So there it is in the back there, and there's the module. Looks like they all look very similar. Different pinouts of the module. Parking brake actuator, parking brake switch, ground circuits, power circuits, fluid level switch, wheel speed sensors again, so we can see what kind of wheel speed sensors these are. Hall effect type switch that measures vehicle speed by measuring your elector wheel located at each wheel. As the wheel spins, a digital square wave signal is produced. There is no separate ground wire. The signal is superimposed onto both wires. This signal frequency will increase with an increase in wheel speed. And this is where the one that said don't unplug the connector while it's on, and it will cut power if it is. And then for a signature test, actually there's a you need to use a 100 ohm resistor in order to test it. So it says set it up like this. So you got 12 volt power there. On the return line, you gotta break it, or not necessarily break it, but you need to put a 100 ohm resistor in. You're gonna test on both sides of the resistor as it's going through, using that diagram as a guide, and then it will give you a little bit of voltage. Not going to be a ton, I don't think, in this case, but it will give you some voltage. All right, so that is ABS. Hopefully you learned a few little tips and tricks, and some of the modern ways to test them are not as easy as it used to be. Just like everything else nowadays, it's not nearly as easy as it used to be back in the old days, right? So hopefully you got a few little tips that'll help you out maybe tomorrow in the shop. So let's talk about next week. Next week, we are continuing on our OEM specific training, VW and Audi this time, and actually a little bit of Porsche in there too. We'll say VAG, so Volkswagen Audi Group would be what that is. So same time and same place. We're going to walk through all the various differences between that brand and what makes it unique from other brands. So 6 to 9 Eastern, as always, join me on Zoom at snapon.com/OT. You can sign up there. Or the 6 p.m. class goes live to YouTube at youtube.com/Snap-on Diagnostics. And then the 9 p.m. Eastern class goes to my Facebook page, which is facebook.com/SnapOnJason. All one word, no dash in the Snap-on, and you can watch it there. Now, if you want to see any of the other classes in this series, anywhere from ADAS to Honda, OEM specific training, and everything in between, this tonight is episode number 87. So, kind of amazing that we've come this far, and we're going to hit 100 by the end of the year. So if you want to subscribe to the YouTube channel, you can just hit that QR code right there if you want, or you can just go to youtube.com/Snap-on Diagnostics and subscribe there. And you can check all that out for free at any time. Also, we have more than just these classes there too. We have hands-on training for the tools. We have the different module training for the tools, other quick tips and quick fixes get posted there. We're approaching 500 videos on the channel, so definitely worth it if you want to find some tips and tricks and techniques and things like that. Good place to go because it's all free. All right. Now for questions. Before I get to that though, if you are watching on Zoom and you came in a little late and don't know where to get the questions, you can feel free to use the Q&A button that's on there. It may not be there actually. I'm just realizing that. So if you don't see a Q&A button, you can still use the chat button and then just send me a chat, and we could do it that way as well. That'll Okay, and then I see there's some on YouTube as well, so I'll get to those in a second. Before I do, I want to make sure I mention my buddy Keith, who also does free training for diagnostic tools. So on Wednesday it is on Zeus and Zeus Plus, and on Thursday it is on Apollo and Triton. It's only a one time per night, so it's 7:30 Eastern, 6:30 Central, 4:30 Pacific. You're going to sign up at snapon.com/OT. He's on the right hand side of the page there. I'm on the left hand side. And then it's about an hour and a half, hour and 45 minutes long. The first hour is going to be setup functions. Let's make sure we talk about Snap-on Cloud. We're going to talk about Security Link. We're going to talk about code to completion using Fast Track Intelligent Diagnostics as a guide. And then he takes a 5-minute break. After that, he goes through the scope and meter functions on the tools as well. So it's a very thorough class. It's designed to kind of have the tool in front of you, watching him, what he does on his screen, and following along there as well. So definitely check that out if you're interested. All right, let's get to questions. Looks like we are clear on Zoom for the moment. So let's go over to YouTube. Nick is checking in, saying hello from England, as he always does. It is very late. It is time for bed. He must be a night owl like me, but hey, thanks for joining us every single week. Curtis Connolly says hello from West Texas. Welcome. Thanks for joining. Let's see. Nick says, yep, my usual wrenching doesn't fix cars, information fixes cars nowadays, right? And the more information you can get, the better. Claude says, can I share in text where to go for the training in the Zeus? Claude, do you mean the actual Zeus training I just talked about for Keith? Or do you mean the built-in training on the how-to guide? I'm thinking it might be the how-to guide, so give me 1 second. I will show you how to do it. So you got to make sure there's no car. Just make sure it says no active vehicle. And then you'd go into guided component tests, right? And then pick North America. I would assume you're in North America. You might not be in North America, but it's going to give you a database to choose. So in our case, we can only choose North America. And that's the very first thing. It's classes right there. And then how to is where all of that stuff is. So if you go in there, it's going to be in there. It's the first couple 20-minute classes. So 20-minute anti-lock braking, 20-minute brake electronics are in. Plus, of course, all the other stuff that's in there, knocks and immobilizer and ignition and stuff like that. So all that stuff is like I said, readily available. So if I just go make sure there's no vehicle, because otherwise it's going to be in the vehicle menu, guided component tests, database, classes, and then how to. And that's all in there. Hopefully that answers your question, Claude. All right. With that, Lobo says, thanks for your time and great session. Thanks for taking the time out to teach the classes. And thank you, Mr. Lobo, for taking time out to learn. And it's always good to be improving, right? I know there was just a huge training class down in Nashville this past weekend, and I bet you a few of you went to that STX training down there. A lot of excellent trainers down there as well. They had like 400 different classes or something silly like that's amazing. But there's so many people that still want to have that training. You need to continually be learning, as evidenced by this class that I just went through, and it's just scratching the surface because I only have like half an hour. So always be learning because things are always changing, right? So always great to see the same faces coming in here week after week and more new faces. So thank you for that. All right, with that, thank you very much for spending a little bit of time with me, increasing your knowledge on ABS systems. Hopefully you'll join me next week for VAG, Volkswagen Audi Group OEM training. And with that, enjoy the rest of your week. Enjoy your weekend. Have a good night and take care.